All right, so we're going to talk about one last major tissue called the pancreas. Notice how I didn't call it a gland, I called it a tissue. The glands are the ones, again, that has their almost primary role is just to secrete stuff, just to secrete endocrine signals or peregrine, what have you. The pancreas is there to produce exocrine and endocrine. Where you can find it is you're going to find it in the upper portion just behind the stomach, right next to the very beginning of the small intestine called the duodenum. And what it's ideal for right there for the digestive system because it secretes its exocrine, remember the stuff that goes outside the body, into the small intestine. While the endocrine functions are well dispersed throughout. These tissues, these endocrine tissues, are called islets, and there's 4 types of them, and you'll find 4 cells neatly around these islets. You got alpha cells, beta cells, delta cells, and F cells. Alpha cells produce glucagon, beta cells produce insulin, delta cells produce somatostatin, and F cells produce a pancreatic polypeptide. Sounds like something that Sylvester the cat would have a little bit of a problem saying. So we're going to go ahead and just focus on glucagon and insulin for now, because somatostatin we're going to talk about in a little while. When I say little while, I mean ANP for a little while. So what's neat about insulin and glucagon? They are the guys that are working together to try and keep blood sugar levels within a specific range, 80 to 100 milligrams per deciliter. If it gets too high, insulin will bring it back down to 80 to 100. If it gets too low, below 80, glucagon's going to try and work its magic to bring it back up and keep it in 80 to 100 milligrams per deciliter. So what glucagon does, its main objective, again, is to bring the low blood sugar level back up from below 80 to 100 and maintain it at 80 to 100, especially during fasting. Fasting meaning that you haven't really eaten anything in like 2-3 hours. What it does is that it will find sugar storages throughout your body, particularly your liver, and this sugar storage is called glycogen. What it's going to do, it's going to break it down. Glycogenolysis, it's a word that you're going to care about in AMP4. It's also going to take other stuff from the body that's been processed and used and try to remake it into glucose and then push it back out into the body. Again, it's happening in the liver. The liver is pretty darn amazing. I tell you what, you should take good care of your liver. So it's going to make new sugar from old broken down products, and it's going to take sugar from the storage and try and keep that blood sugar just right. Insulin is going to try and do the opposite. You got too much sugar hanging out in your blood. You're above 100 milligrams per deciliter, and it's going, whoa, hey there, mate, let's turn it down. Let's put that sugar somewhere else. So it's going to start, the insulin's released, that glucose is going to go into cells, and it's also going to go into the liver and the muscles, and it's going to be that sugar is going to be put into storage again. Whatever you take away with glucagon, you got to return. You got to restore. You don't want to be deprived of those storages. So with diabetes, which means it comes from the term diabetes mellitus, which means sweet urine, which unfortunately its origins and how they determined what you had back in the 1800s explains pretty much how they figured out that you had diabetes mellitus. Doctor would come along, have the person pee into a bottle, they take a sip and go, yep, that's sweet. You got diabetes. Diabetes just means peeing, and mellitus means sweetly or honey. So you have a nice sweet honey urine. Now there's 2 types, well actually 3 types, but we're going to talk about 2 for now. Type 1 and type 2. Type 1 is, well, insulin is no longer being produced. Some type of genetic issue, maybe your immune system says, you know what, I really don't like that beta islet guy. He's ugly, let's kill it. So it goes along, kills off that beta islet, you're no longer making insulin. which means that you have to take insulin. You have to take the insulin injections. You have to watch your sugar levels very closely. You have to do your calculations and all that. Type 2 is more of a result of, well, 1, genetics, 2, poor living. We'll just say poor living. You're not exercising very much. You're eating way, way, way too much sugar. Don't look at me. Okay, fine. I'll work on my sugar levels. Anyways, type 2 is the, hey, you know what? Insulin, you're a great guy, man, but you're being really, really, really needy. So the receptors get pulled away. They get down regulated. Remember what down regulated means? The receptors get pulled away and the cells become less sensitive. And in this case, in type 2 diabetes, the receptors have become less sensitive to insulin. They have become down regulated. With that is the very, very basics of our friend the pancreas and what it does with glucagon and insulin. Type 1 being an issue with production of insulin, and type 2 being an issue with the receptor. With that, I will bid you adieu.